In this video, we're going to talk about function notation, specifically with tables and graphs. All right, so before attempting this lesson, just make sure you're comfortable in general. What is a function? What's an input versus an output? X and Y. And then the coordinate axis, what do points on a graph look like? All right, so we need a shortcut for the phrase. We put 3 into the function and we get out 5. All right, that's a lot of words for mathematicians. All right, they want to make just symbols do all the work for them. One way you could do that is like I've been doing it in a lot of videos is 3 arrow 5. So I put in 3 as my X value and I get out 5 as my Y value. But once I start doing multiple operations with functions or trying to do functions in other scenarios, this arrow is not a great notation because arrows can get kind of confusing, especially if I had like times 2 there. Is the 2 part of the function thing or is it after? So I just want to figure out a better notation for saying I put in this into my function and I get out that. And the thing we're going to use is called function notation. It's a notation for functions. All right, it looks like this. F of x equals y. So f is going to just be the name of the function. And we use f for function. We can call it a bunch of things. I'll use g and h a lot because they're the next letters in the alphabet. But we give our function a name, in this case f. The input that we're putting in goes in the parentheses next to the function name. And the output goes on the other side of the equal sign. So if I wanted to do, in the previous slide, we had 3 arrow 5. That would look like this. F of 3 equals 5. I would have put in 3, I get out 5. All right, so now we're going to use this function notation. All right, try to use it in conjunction with ways we've talked about functions. So one way we talked about functions is with tables. All right, so for this one, we have our table. We're going to find these different function values. So our function is called f. And the first thing I'm going to do, whatever is in the parentheses is our input. So this is our x value. So I want to go to when x equals 2. And what y value corresponds with that, where I just go straight down the table. And the y value that corresponds to that is -4. So that's going to tell me that f of 2 equals -4. When I put the input 2 into my function, I get out -4. Right. F of 6. My x value is 6. And its corresponding y value is 2. All right, so this is going to be equal to 2. When I put in 6 into my function, so I'm taking 6 and putting in my function, I get out 2. All right, go ahead and try f of 11 for yourself. All right, what is f of 11 going to be equal to? All right, I'll tell you in 3, 2, 1. F of 11 is 3. All right, again, for the same reason, my x value is 11. And when I plug that into my function, I go to the output 3. All right, another way we can do this is solving an equation that involves our function notation. So just remember, I'll rewrite it, f of x equals y. So in this first one, f of x equals 12. This 12 is our y value. So we're basically just going to do the same thing we did in the last slide, but in reverse. So 12 is the y value that happens there, and that corresponds to the x value, 9. So if I want to solve this equation, f of x equals 12, that happens when x equals 9. Because if I plug 9 into my function, I get out 12. All right, same thing, f of x equals 2. And I'm going to find 2 as a y value. All right, this is my y value. So it happens there. You'll notice it also happens there. So in this case, I'm going to get 2 answers, x equals 1 and x equals 6. All right, because if I plug in 1 or 6, I get 2 as an answer. And it's fine to get multiple solutions for a problem like this, because this is a function, but I'm going backwards from the function, not the original direction. So my y values are 2. If I plug in the x value, 1 or 6. And the last one, go ahead and try on your own. All right, f of x equals 0. All right, I'll show you the answer in 3, 2, 1. The answer is x equals 7. And again, because of that, when my y value is 0, my x value had to be 7. All right, so one more chance to kind of try one on your own with a brand new table. All right, try these 2 on your own. All right, I'll show you the 2 answers in 3, 2, 1. All right, first up, f of 5 is -4, so my x value is what's in the parentheses, is 5. My y value is 4. And the second one, f of x equals -2, I get 3 and 11 because my y value is -2. My x value I was looking for was 3 and 11. And again, it's fine. You can only get one answer for these ones. You only get one answer because it's a function, but you can get multiple answers when you solve. All right, so now we're going to do the same thing, function notation, but we're going to do it with graphs instead. And really, the only thing you have to remember is that there's a relationship with the x and y points, is that x is your input and y is your output. So there's a relationship between your function and the graph. All right, every point is input output. Every input output is a point. All right, I'll talk about this a lot throughout the year, so it's kind of a really important thing to remember. In this case, we're talking about our function g is given by this graph. So this is our function g. All right, it's just the next letter after f. All right, and we want to find g of -1. So my x value is -1. So I'm going to go to my graph. And my x value is -1 is there. And I'm going to see which point on my graph has an x value of -1. If I go straight up from here, hit that point there, and that y value is 3. So since the point -1, 3 is on my graph, when I input -1, I get out 3. All right, what about g of 1? All right, 1, the x value is there. I need to go down to my graph, and I see that's the point 1, -3. So when I input the x value 1, I get out the y value -3. All right, and this last one you can try on your own. All right, g of 2. All right, what's g of 2 going to be? I'll tell you the answer in 3, 2, 1. G of 2 is 0. All right, because I hit the point right there at 2, 0. All right, so I just go to that x value, and I go up or down to my graph and figure out the y value. Just remember, all these answers are the y value that go with that x value. All right, now we'll just do the same, or the opposite, just in reverse. All right, g of x equals -4. So remember, this is my y value. So I'm going to go to my y value, -4. And now instead of going up or down, I'm going to go across to my graph. That happens there. That x value, that's when x is, let's just say -2.5. It's not exactly on the line. All right, -2.5. All right, that's the x value that would give me that y value. All right, g of x equals 0. 0's here. I can go to the left and go to the right. And again, remember, it's fine to get multiple answers for solving. So here I actually do get multiple answers. I get the x value -2. I get the x value 0 in the middle, and I get the x value 2. All right, all three of these points have a y value of 0. And again, last one, try on your own. All right, what would g of x equals 3? All right, what would x be equal to? All right, I'll tell you the answer in 3, 2, 1. We have that x equals -1, and x equals about, I don't know, 2.25, something like that. Not exact, but when y is 3, I have this point here at -1. This point here, which is a little bit past 2. That's why I put 2.25. All right, but if you put 2, kind of close enough. All right, those are your solutions for that equation when my y values are 3. All right, here's one more chance for you to try on your own. I evaluate and solve these two things. I'll show you the answer in 3, 2, 1. And here are the solutions. So f of 3 is 2, because I'm going to put in the x value 3. I get out that y value 2. If I solve f of x equals 1, I get 0.5, because if I had the y value 1, the x value had to be a half, 0.5. All right, so this is how we find function notation using graphs. All right, so go ahead and practice. All right, again, using tables and graphs. All right, you'll be tested on both of them. All right, so make sure you're comfortable using function notation with tables and graphs.